Now down here we ask for the domain and the range. So it's going to turn out that you simply ask how far left does the graph go and how far right does the graph go. But it may actually help your understanding if you thought of it this way, or at least deepen your understanding. If you were to pick any point on the graph, say this one, you would say that in terms of x values, because the domain is the set of inputs, and in my case we're using x for the input variable. So let's pick a point here. What kind of x value does it have? Well, look down at the x-axis, it's x equals 1. To pick another one, for example, this point right here has an x value of about 1.5. So all of these points that I'm pointing at exist on the curve. All I'm doing is going to the x-axis to see what the corresponding input is so that I include it in my domain. So the idea would be, here's a point right here whose x value is -2. Here's a point right here that if you went up, you'd see that the x value is -3. Well, you could do this all day. So here's a point, for example, that this point right here that I'm pointing at has an x value if you looked up at -2.5. Imagine doing this for the next 5 hours. You know, oh, this point right here has an x value of -1. This point has an x value of 0. So the idea is if you were just to pick any point on the curve and look down at its corresponding x value, and you did that for several hours, eventually you'd have so many dots down here, you'd have this kind of look to it. You'd plotted so many dots on the real number line, you'd have this. And this is exactly the domain. This is the region on the real number line between -3 and 2, and if you want I'll stick 0 in the middle, but this reminds me back in algebra where they would give us these graphs and we had to convert the graph into some inequality notation. That's exactly what we're supposed to do here, is express our domain in inequality notation. In fact, we'd put the open circle right on the real number line and the closed circle here. So that's the idea, is that we're taking a two-dimensional figure and sort of mapping it into this one-dimensional answer. With inequality notation, one way to represent this region would be that x is less than 2, strictly less than 2 because it's an open circle, meaning that 2 is not part of the domain. And at the same time, x has to be bigger than or equal to -3. And we put the equality there because -3 is actually part of the domain. At that point does exist on the curve, unlike this one here. So the idea would be that this is inequality notation. And to show you interval notation, sometimes what I do is I do an intermediate step where I show you what's called the compound inequality, where I put these two together. So it's still going to be inequality notation, it just combines these two statements. Write the small number here, the big number here, and then you're going to say that your x values are between, and look, I physically put my x between the small number and the big. So for example, for this problem, the smallest number is -3. And then I'll write an x in between, and 2 was my bigger of the two. Write less than symbols, and then at the end you can decide whether there should be a line there to indicate whether the 2 and the -3 should have been included, and in our case it was the -3 that had the closed dot, so I'm going to include that. So this says the same thing as that. It says that x is less than 2, just like this says x is less than 2. And the other one's a little harder to explain because it got flipped. This says x is bigger than or equal to -3. This, because we reordered the -3 and the x, we had to actually switch the sign. If x is bigger than this, then this must be smaller than x. And that's what this says. -3 is less than or equal to x, which is exactly equivalent to x is bigger than or equal to -3. But the nice thing about this is when I move to interval notation, we're almost done already. Interval notation does exactly what I just did with combining this, except when you write your small and your big numbers, you don't stick an x in between and you don't use less than symbols, you just put a comma. It's just assumed that since we're talking about the domain, that we're talking about the input variable, which for our case was x, and then you use parentheses or brackets to indicate whether you're to include those endpoint x values. So the idea is for my problem in interval notation, wow, look how I spelled notation. This is kind of comical. Notain, you know, this is great. Sometimes I like that I make these mistakes just because these videos are hard to watch for any length of time. So for my problem, the small number was -3, comma, big number was 2, and with interval notation, the way to indicate that you're supposed to include an x value is to use a bracket, and the way to say that we're supposed to exclude an x value like 2 is to use the parentheses. So this indicates that 2 is not part of the domain, but for example 1.9999 would. I could pick a point really, really close to that, and its x value would be about 1.999. So that's domain. Now to determine the range of the function f, if you look at the definition of range, it's the set of all outputs, which in our case we're using the notation f of x. to denote our output. So the range would be the set of all outputs f of x, or sometimes just referred to as y. So if I say y in the video, I also could say f of x. Now, one way to look at the set of all y values or outputs would just simply be to look at how high and how low the graph goes. So for example, the lowest the graph goes is a y value of -5. The highest that the graph goes is a y value of 4. So looking just at the y values, not x, I can see that we have y values between -5 and 4 on the graph of f. So you could simply say that the range is f of x that are less than 4 and at the same time bigger than -5. Then the convention is, if there's no open circle here, that we are to assume that the curve actually takes on the point 0, 4. So I'm assuming that 0, 4 is a valid point on the graph. So 0 is part of my domain. You could go back and look at that, and it was. And 4 would be part of my range. So since I want 4 as part of my range, I need to include it by putting a line here saying that f of x is less than or equal to 4. And then likewise, you see the closed dot here, meaning that f of x could actually take on the output of -5. So we should indicate that by putting a line there. Now, just to make sure that you understand, when we say that f of x is less than or equal to 4 and f of x is bigger than or equal to -5, we're talking about all y values, not just integers. So to point this out, look at this point right here, which is indeed a valid point on the curve. Its y value would not be an integer. In fact, it would be something like, let's say, -3.5. So if I was to go over and put a dot right there, and then just to pick a few more, this is a y value of -2.5. And this is a point whose y value would be -1.5. But also you could even pick points like this one whose y value might be, say, -1.1. So there's infinitely many there, and we just can't list them all, and that's why we choose to use this inequality notation. In fact, can you imagine if you did this all day long, just starting to pick points and going over to the y-axis and continually plot a little point there on the y-axis indicating what the y value is for all these points. If you did this all day long, what you would get on the y-axis is a shading, and that one-dimensional interval there would be exactly what the range is. If we could turn this graph sideways now, remember this point was included and this point down here was included. If you could turn this sideways, what you would have is, starting at the number -5, you'd have a closed circle, and ending with the number 4, you'd have a closed circle. What you'd have is indeed the region on the real number line that represents our range, and you would represent that as that your outputs are less than or equal to 4, and at the same time your outputs f of x are bigger than or equal to -5. And sometimes we don't use f of x, we use y. It's actually better that you know that they both mean the same thing. And sometimes we like to combine these and say that f of x is less than or equal to 4 and at the same time bigger than or equal to -5. And we combine that into what's called a compound inequality. And if you were using y's, that would look the same, except you'd be using y instead of f of x. So all of these are acceptable ways of writing the answer in inequality notation. But remember, we are also to write our answer in interval notation. So in interval notation, what you do is you take one of the last answers we did in inequality notation, which were these two, which are both in compound inequality form. And the idea is that since we are asked to find the range, you need not write the output variable f of x or y. It's assumed, since you're talking about the range, that you're talking about the set of all outputs. So you need only look at the smaller value on the interval, which was -5 on the real number line, put a comma, and then write the bigger of the two numbers that were on the interval on the real number line, which in this case was 4. Then you need only decide whether you're supposed to include or exclude those numbers. And in this case, we were to include both of them because of what I said before. Remember that if there's no open circle in the graph, you are to assume that that value is actually taken on. So we are going to put a bracket there, and because of this closed circle, we included the -5, so we're going to put a bracket there. If ever you want to exclude a value, you use a parenthesis instead.